Hello, hashtag happy Septandy. Or is that hashtag happy hashtag Septandy, which is different from hashtag happy hashtag Septandy. In a previous video, I went over a couple ways you can automate your MAME debugging experience. And in the second half in particular, we talked about the Lua programming language and how you can use Lua to script many of the objects inside MAME. I highly recommend that you watch that video first, as we will be building on that Lua stuff quite directly in this video. Today, we're going to build a performance meter. In fact, why do 1 meter when you can do 2? The first meter will tell us how much time before the current frame is done being drawn, and that's a nice proxy for telling us how much work we've been able to get done during the course of the frame. The second meter will give us a running average of that same thing, so that as we run our program over time, that second meter will tell us a more stable reading of how performant our code is. So without any further ado, this sounds too exciting for me to continue rambling on and on and on. I really want to get to seeing how this thing works, so let's go! As a reminder from the last video, the code that we wrote had 2 trigger points. One trigger point occurred every time that MAME decided that it was done drawing the frame, and that would be our trigger point to draw our overlay. That function made use of this variable captured time, and that was updated from our second trigger point. That second trigger point was when a certain memory location was written to. In this case, it was hex 70, which is written to by color basic. This represented the console.in buffer flags. So whenever the console.in buffer flags was set, the method capture time until vblank would be called, and capture time until vblank would update captured time. And then whenever the frame was done being rendered, we would use captured time as part of the text in the draw overlay. We're going to do something very similar today, but first, that right tap, that second trigger point, we need to change. One of the beautiful things about writing your own performance tool for your own program is you can allow them to cooperate. So I can actually pick a memory location that my code writes to for absolutely no reason other than to trigger some of this code in the meter. So here's the code in my game that swaps buffers. It waits out the rest of the frame, and then it tells the VDG to go ahead and swap buffers. Just before I wait until the end of the frame, that's when I can do my trigger point. I'll write to this address 7800, which I know is not written to or used by my code, and should be well enough far away from the stack pointer for this to interfere with stack space. And at this point in the game, we've done all the processing and all of the drawing that we're going to do for this frame. So this is a great time to ask, how much more frame is there? How much of the frame rendering did we use up with all the processing and drawing that we did in the off-screen buffer? Here's the skeleton code for the script. As before, we print a debug message just so we know the script is running, and we grab a hold of the CPU device, the memory space device that we're putting the tap on, and the screen device that we're using to render. I'm also going to reserve 3 global variables. So this is going to tell me the progress I made it through the current frame, and I'm also going to keep a running average. What I'd like to do is to have 2 meters, one that tells me what's going on with the current frame, and another that shows me the average. And to calculate that average, I'm going to need to know the sum of all the frame values that I've measured, in addition to the count of those frame values I've measured. That way I can just do the sum divided by the count to get the average. When the frame is done being drawn, we're going to call the draw overlay function. And when hex 7800 is written to, we're going to call capture frame progress, which will update those variables. Let's start with capture frame progress. To start with, we're going to do something very similar to what we did in the last video. This tells me how many seconds until the v-blanking period starts, and we're going to convert that to a double. And so I put that here into seconds. It's actually going to be a fraction of a second. And then I'm going to multiply that by 60, and that tells me the frame value. So this will be the fraction of a frame that's remaining to be drawn by the time this was called. And then to calculate the average, I'll just add the captured frame value to my running sum, and I increment the captured frame count. And that brings us to the overlay. The overlay is going to draw 2 different meters. So rather than writing all the code to draw a meter twice, I'm going to have a helper function which just draws a meter. And I'm going to call that helper like this. The first meter tells me the current frame progress. So I'm going to have this helper draw a meter, and it's going to take the upper left-hand corner, the x and y coordinates, so it knows where to draw it. I'll give it a title, and then I'm going to give it the value that it's going to be displaying. So for the current frame progress, we're just taking the captured frame value that we already wrote in the capture frame progress function. The second meter, which tells me the average, is below it. Again, the upper left-hand corner coordinates, the title, and its value is simply the sum divided by the count. And that just leaves the helper. First up, I need to figure out where the rest of the coordinates for the box will be. It took a bit of trial and error, but what looks good to me is to set the x-coordinate of the right-hand side to be 30 units to the right of the left, and for the lower, the down portion, the y-coordinate of the down, to be whatever the up is plus 60. So basically a width of 30 and a height of 60. Value is going to be the value that I display, but I'm going to want to change the units a bit. It's going to be a fraction of a frame. And what I'd like to do is draw it as a percent with an extra digit of precision after the decimal point. So something like 25.7%. So I multiply by 100 to get a percentage, and then I'll multiply by 1,000 to get that extra digit of precision. I'm going to do math.floor to convert it into an integer, but to get it to round up or down properly, if you just add 0.5 first, that ensures that if it were below 0.5, then it won't affect anything and it will continue to round down. But if it were above 0.5, then by adding this, I'll ensure that I round up to the next integer. And finally, I divide by 10 so that that extra digit of precision will appear after the decimal point. So this is going to be the value I use to display in text. First up, let's draw the title. We'll just do that a couple units to the right of the left-hand side and then several units above. And then I'm going to draw the bounding box. This is just going to be a static box. I'll have it be outlined in cyan. And I'm going to fill it in with a solid black. That way the moving meter can be very easily seen. And I already have the coordinates of the corners already calculated for me. The fun part is the moving meter. Most of my coordinates are already set. The left and right-hand sides are going to be the same as the bounding box. The bottom is going to be the same as the bounding box. The thing that changes is how far up it needs to go. The value I'm displaying, since it's a fraction of a frame, I will multiply that by the full distance that we have between the lower and the upper sides of the bar. And then applying that fraction to that difference gives me the vertical length that I want the bar to be. So if I subtract that from down, that will have it start at the bottom and grow up just as high as it is and no higher. And a quick way that I use to verify this in my mind is if the value runs from 0 to 1, what happens when value is 0 and what happens when it's 1? If value is 0, meaning there's no frame left, this is all 0, and then the meter has no height. It's just sitting it down and going nowhere. In contrast, if the value is 1, a full frame, then we'll have down minus down plus up. So the top of the meter will be the top of the bounding box and it will go all the way up. And we're just going to make this a solid white. Next, I'm going to add several gradient lines. Think of these as like lines on your measuring cup. This will give you a visual to know about how high the meter is going. So I'm going to use a for loop to draw 8 of these lines. We'll start at the top, we'll go down to the bottom, and our step size will be that distance divided by 8. So for each of these y values, we draw a line from left to right at that y value. And we're going to make this cyan like the rest of the bounding box. And finally, we're going to draw the text containing the value that we're measuring underneath, so we have something to pair with the visual, something more precise. So we'll have the text be at the same left side as the bounding box. We'll draw it just below the bounding box, and this is what we're drawing, frame percent, which is what we calculated up here. And then the text with the percent sign, and then the word frame, a new line, and then the word remaining. All right, so there we have it. We have the top meter for the current frame, bottom meter for the average frame. We got a bit of a nan here. We're dividing by 0 because nothing has started yet. I'm okay with that. Let's start it up. You'll notice it already has started doing something, and that's because that area of memory, 7800, I guess it must be written to during the startup of the ROM. But you'll see nothing's changing. So it wrote to it initially, but then after that, there was nothing. So let's start up the game. Have the game running in a kind of autopilot, so it's jumping and shooting without me trying to. And you can see the current meter is juggling all over the place while the average meter is very slowly lowering into position. All right, we got our meters. I think we should use our meters. Perhaps it's time to do some more optimizing and seeing if we can get those meters to be higher. Well, until then, if you would like to study the code that was in this video today, there's a link in the description. And as always, thank you for watching.